So in the lean software factory, there is a word which is software factory, which is very important. Actually, it's even more important than the lean qualificative added to it. So a software factory means doing software in a way which is very close to a factory, where the two keywords are building and testing. And there is no reason to spend too much time on this, because it's now well understood and well adopted. The principles are easy, the art is very difficult. But all that I'm going to say is totally impossible if you don't have a software factory first. And I will come back to that later on, but it's a key message. So the first thing we do is we try to develop software in a way which is as automated as possible, from conception and coding, but testing, integration, and delivery. And there is a clear ring to DevOps, which was mentioned this morning. It's the same overall goal. The reason software factory is so important is, for me, it's an evolution from the way I was taught software 30 years ago, which is very information technology, very technical point of view. 20 years ago, the stakeholders, the users, were added into the picture, and we stopped talking about IT and we talked about information systems. But it's a static picture. When you talk about factory, you need to see the cycle, the way you produce the software, the way it's used, and how you improve from this. And you discover very quickly something which took me like 20 years to understand, that most of those qualities, openness, agility, the things that you want from your software, they are not a quality of the product, they are quality of the process. And this is why you need to make people before you make products, because actually it's not, it's something which is really part of the big cycle, which is a reason why I'm so excited with this software factory idea. 5S, the 5S from Toyota, actually applies very well to code writing. This is explained pretty nicely by Mary Popendick in her book, but there are other resources. If you Google, you will find them. You will find that the sort, systematize, shine, standardize, and sustain, they apply to software in many ways, and it makes perfect sense. That is, if you want to loving your code means organizing it in a very clean and elegant and proper manner, so that it's easy to come back to it. It makes maintenance easier, and it makes everything else easier. So what is everything else? Number two is discipline, which is mostly standards at the code level, as you mentioned. So part of it, anybody who's done software on large scale know about it. I mean, coding standards is critical. If you have large teams with people who get in and out, if you want to maintain your software over 20 years, if you don't have coding standards, you have simply no chance, and so on. But there is more than this, and I think what you pointed out was very important. That is, a coding standard is not a good practice that you get from your quality department. It's something that the team builds by itself. By itself, it's a team, yeah. And that's a key. First, it brings a lot of quality improvement by itself, and it also allows the next. So it's kind of a Maslow pyramid of proposals here. Number three is you do code review. And if the code is not clean, standardized, and so on, code reviews are terrible. And they are pains, and people try to avoid them. So you need to do 1 and 2 so that you can do code reviews. Code reviews, and you put as a key value of the software organization the notion of elegance. So that's something you want to write elegant code. And if you look at all the companies in the Silicon Valley which are successful because they write code, they have a lot of pride in the code that they write. And that's something you need to build. And you build it bottom up and not obviously not top down. You try to remove stuff because this is the right time to remove stuff. So you're back to to HIB less code idea. And last but not least, you develop this culture of gardening the code. The code is not something that moves, that's a live object. Last year, there was this great talk from Google who explained to us that at Google, 50% of the code is changed monthly. So when you tell this to regular IT organization in France, they just say, this is not possible. And obviously, if you produce code with a terrorist approach, this is not possible. If you don't do code with this type of philosophy and where it's sort of a bottom-up production, there is no way you can refactor your code all the time. And to come back to the point that Michael was making, yes, iterative process produce junk. That is, if you do things iteratively, it doesn't matter if you're very smart and you have only Stanford PhD, you're going to produce junk. So there has to be a process of cleanup and refactoring all the time. You also need architecture. That would be a lesson from the third part. Another key thing that I've learned, much too late, but is the importance of Gemba walks. And the short summary is you cannot transform an organization if you have no clue what's happening in it. And to be very frank, it's now obvious to me that 2 years ago, I had absolutely no clue what was happening in my software organization. And so that's sort of the number one reason for doing Gemba work. Number two is it has sort of two benefits as far from the team perspectives. Eventually, when I get smarter, I will teach them how to self-improve, but I'm not there yet. But what I can tell them is the vision, and what I can tell them is their place within the organization and smooth the collaboration between all those teams. So my key role is to make sure that the true north is shared by everybody, and my second role is to detect that people should talk to another more than they do. So that's the practical value, and on the human side, the value is simply recognition and pride, and then the third benefit is that I'm getting less dumb as I'm doing this.